Imagine a cosmic intruder, a diamond sphere the size of a mansion, hurtling through the silent void of space toward our fragile blue marble. Space is a shooting gallery, with 4 billion meteoroids falling into Earth's gravity well every single day, most burning up as harmless streaks of light. Usually, these visitors are just tiny stones that surrender to our atmosphere. But today, we are changing the rules of physics for a grand experiment. We are taking a 30-meter diamond ball and pushing it to velocities that defy human comprehension, starting with a modest 3,000 kilometers per second. At this speed, the air itself becomes a wall of fire as atmospheric molecules begin to undergo nuclear fusion upon contact with the sphere. The resulting plasma heating is so intense, it might vaporize our diamond traveler before it even touches the soil, turning it into a ghostly streak. But if it survives, the impact releases 1,000 times more energy than the most powerful nuclear weapon ever detonated by human hands. An entire region would be wiped clean in a heartbeat, leaving nothing but a massive, smoking scar on the face of the Earth's crust. Yet, in the grand scale of the universe, 1% of the speed of light is actually quite slow, almost boringly pedestrian for a cosmic event. Let's turn the dial up and see what happens when we invite relativistic effects to the party by moving closer to the ultimate speed limit. As we reach 99% of the speed of light, the very laws of chemistry that hold the diamond together simply cease to function. The sphere is no longer a solid object, but a swarm of carbon atoms, flattened into a pancake by the strange physics of Lorentz contraction. We wouldn't even see it coming. The object is moving so fast that light itself can barely keep pace with its terrifying approach. Each individual carbon atom now carries 70 billion electron volts of energy, turning the atmosphere into a transparent ghost that the sphere passes through. Air molecules don't move out of the way, they penetrate the diamond pancake, getting stuck inside and adding mass to the falling projectile. When this superheated ultra-dense mass finally hits the surface, it doesn't just crash, it disintegrates the very fabric of the ground. It rends the Earth apart, creating a cone-shaped channel through the lithosphere and punching a hole so deep you can see the mantle. This impact releases 50 times the energy of the asteroid that ended the reign of the dinosaurs, signaling a new mass extinction event. The sky would turn to fire and the oceans would boil, leaving the planet a charred husk of its former vibrant self. But even this is not the limit of our curiosity. As we prepare to add even more nines to our velocity, we push the experiment further, reaching 99.99999999% of the speed of light, where the physics of the mundane fully dissolves. Now, every single carbon molecule in our diamond sphere carries a staggering 25 trillion electron volts of kinetic energy. This energy is comparable to the high-energy particles circulating within the tunnels of the Large Hadron Collider in Switzerland. At this velocity, the diamond ball hits the Earth with the total kinetic energy of the Moon moving in its orbit. This isn't just an impact anymore, it is a planetary-scale injection of energy that defies everything we know about survival. The projectile punches a hole so massive that the Earth's mantle is disturbed, causing the entire surface to ripple like water. The friction and energy release are so extreme that the crust begins to melt, turning our green world into a sea of magma. Life on Earth, from the deepest bacteria to the tallest trees, faces a probability of extinction that nears an absolute certainty. But our thirst for destruction is not yet quenched, and we decide to push the laws of reality to their ultimate breaking point. We add just a few more nines, 99.999999999999999999999999999999999999999999% of the speed of light. This is the speed of the Oh My God particle, the fastest object with mass ever observed by human scientific instruments. In 1991, a single proton with this incredible energy plowed into the atmosphere over Utah, baffling scientists around the globe. The cascade of subatomic particles formed from that one proton's collision was more powerful than anything the LHC can reproduce today. These mysterious particles are detected a few times a year, seemingly arriving from the chaotic hearts of exploding distant galaxies. No one knows exactly what cosmic accelerator could launch a particle with such haste or why it didn't slow down on its journey. Now, imagine our 30-meter diamond ball trillions of times more massive than a proton moving at this oh my god velocity. At this extreme, modern computer technology fails us. no simulation can truly capture the violence of such an encounter with matter. However, we can use the fundamental laws of physics to roughly outline the terrifying picture of what would follow next. The diamond ball sweeps through the atmosphere like it isn't even there, disappearing into the Earth's crust in a microfraction of a second. A cloud of expanding plasma and blinding radiation begins to erupt from the entry point as energy pulses through the planet's core. Just 40 milliseconds after the initial contact, the far side of our planet begins to bulge and expand outward. The diamond projectile and the cascade of high-energy particles it creates rip through the Earth's core like a needle through silk. Under the stress of this impossible energy, the entire planet begins to glow brighter than the sun from sheer overheating. The impact is so violent that it physically shoves the remains of our world into a completely different orbital path. But orbital mechanics are irrelevant now, because the Earth, as a cohesive celestial body, has effectively ceased to exist. The energy deposited by the diamond sphere is 10,000 times greater than the Earth's own gravitational binding energy. This means the gravity holding the rocks, oceans, and mountains together is completely overwhelmed by the explosive force from within. The Earth doesn't just crack, it explodes into an ever-expanding cloud of superheated plasma radiating into the cold dark. Especially energetic flows of matter jet into deep space, following the original direction of the diamond ball's terrifying impact. The Sun itself would be choked by the massive waves of planetary dust and debris that suddenly envelop the inner solar system. Nearby planets like Venus and Mars would be blasted by an incredible high-energy plasma shockwave, scorching their silent surfaces. This is the ultimate firework display, a catastrophic transformation of a living world into a transient flash of cosmic light. It is a sobering reminder of the sheer scale of the universe and the fragile nature of the matter we inhabit. Kinetic energy is a simple concept in a classroom, but at relativistic speeds, it becomes a weapon that deletes planets. We are used to thinking of diamonds as symbols of eternity, yet here, one was the catalyst for the end of time. This thought experiment pushes our understanding of reality to its limits, showing where math and imagination finally meet. While we will never see such an event in our lifetimes, the physics behind it governs the stars and galaxies. Our universe is a place of quiet beauty. But beneath that, calm lies the potential for absolute, blinding chaos. If you enjoyed this journey to the edge of destruction, consider showing your support for more deep dives into science. The universe is full of mysteries waiting to be unraveled, and we have many more cool releases coming your way soon. As the dust of our exploded planet settles into a new asteroid belt, we are left with a haunting perspective on existence. In the vast, uncaring theater of the cosmos, the difference between a beautiful gemstone and a world-ending weapon is simply velocity. We often perceive the laws of physics as rigid constraints, but they are also the architects of both creation and total annihilation. This diamond ball experiment is a reminder that our safety is maintained by the immense, empty distances between us and the stars. While a relativistic collision is unlikely, the oh my god particle proves that the universe is capable of producing such terrifying energy. We live on a tiny, fragile speck of dust that has, so far, been miraculously spared from the most violent whims of physics. It makes our everyday worries feel small when compared to the potential of a single diamond moving at the speed of light. But this realization shouldn't bring fear. It should inspire a profound sense of awe and curiosity about the mechanics of reality. To understand the universe is to appreciate the delicate balance that allows life to flourish in a sea of high-energy chaos. We are the only part of the universe that has developed the eyes and the math to witness its own potential destruction. Every discovery we make about relativistic speeds and subatomic particles brings us closer to mastering the environment we inhabit. Perhaps one day we will use this same kinetic energy not to destroy worlds, but to propel ourselves toward distant, new homes. Until then, we must remain vigilant observers, documenting the wonders and the terrors of the celestial neighborhood we call home. The story of the diamond meteorite is just one chapter in the endless book of what-if scenarios that science allows us to explore. We hope this journey through the extremes of physics has expanded your mind and sparked a flame of scientific wonder. Behind every star and every atom lies a secret waiting to be told by those brave enough to ask the big questions. Thank you for joining us in this exploration of the impossible, and for supporting our mission to make science beautiful. Your curiosity is the fuel that keeps this channel moving forward at nearly the speed of light, exploring the unknown together. Keep looking up at the stars, for they are both our origin and the potential destination for the future of our species. Until next time, stay curious, stay amazed, and never stop questioning the fundamental fabric of the wonderful universe we share.